Hello, my name is Abdurrahman Khattab, and this is my final project, and it's called RAG for Domain Specific QA. The final project is for course CSCIE 222, the Foundation of Large Language Models, Spring 2026. The project mainly is solving a problem. The problem statement is that standalone LLMs often hallucinate and lack reliable domain grounding. I have a specific motivation for this project because I work for a company called Unifor, and one of the areas that I'm pitching every day is the SLM factory and how having an SLM that is focused on a specific subject makes it very subject matter expert and uh, enable much higher accuracy based on reliable domain grounding. The RAG that I built is combining retrieval with generation to improve factual consistency. The goal is to build a lightweight enterprise-style RAG system runnable on local hardware, which was my local machine. The dataset I used is a public dataset, which is IBM Doc2Dial, document grounded customer support dialogues. It has a dialogue of customer support. I'm motivated, like I said, with some solutions that Unifor, the company that I work for, is providing based on the SLM factory concept. And one of them is based on the customer support dialogues. Dark architecture is very simple: question, retrieval, evidence selection, grounded generation, and then evaluation. I use dense semantic retrieval using transformer embeddings, which is EBG, and grounded answer generation using retrieved passages. Like I, s- like I said, sorry, the embedding model is BGE. It uses cosine similarity retrieval, but also for checking, I added a hybrid retrieval using the TF-IDF retrieval just for comparison. The dense retrieval outperformed the hybrid retrieval, and this is what we can see now in the system itself that I created. The generation system, I use Tiny Llama. I tried first some other models, but either it takes too long or the performance is too low, or I had some authentication issues. It is an open access, lightweight, and chat-oriented model, prompting constraint generation using retrieved evidence from the retrieval step. Designed for local execution on Apple Silicon. It worked very well on my local machine. The environment is Python 3.11. I'm using Jupyter Notebook. For Anaconda environment is TF311. My device is Apple M4 MacBook Pro with 16 GB of RAM. I didn't use any cloud GPU. The retrieval results, as you can see here, dense BGE. At recall 5 was 0.35, recall 10 at 0.47, at MIR at 10, 0.1709. Retrieval hit rate was 50%. I understand it's not great, but this is the best I could get with my environment. I tried several other models, but this one was the best. For the generation, I used Tiny Llama. I got baseline token level at F1 of 0.19. This is for the baseline. When I used the dense RAG with Tiny Llama, I got a little bit higher. So the RAG slightly outperformed the baseline. I understand it's not a huge improvement. However, it proves the concept. The improved retrieval quality improved grounded generation. So I tried like I said, several other retrieval before I used the BGE, and I the overall quality of the generation was less, I concluded that it was because of the also retrieval quality. I also tried qualitative analysis. The baseline answers were very fluent but kind of generic. RAG answers was more factual, but only when the retrieval was successful. And it was successful 55% kind of. Retrieval quality remained the primary bottleneck. So if I use maybe if I find a model that is having higher hit rate, the end the final step of generation would have been higher. Grounding quality improved substantially with BGE embeddings. Like I said, I tried before and this was the best. Um, for the lessons learned, retrieval quality is more important than model size in practical systems. My limitations was my limitation was mainly the environment, but I learned that when I had lower quality of retrieval, whatever generation I used, the performance was much lower. Stronger embeddings, of course, significantly improved the results because it improved the retrieval and accordingly the generation. Resource-aware engineering is critical for reproducibility. So the idea here was when I tried something that was not relevant for my environment, it took very, very, very long, and some of them were also crashing. So I was very cautious to choose the right data set and the right number of records inside this data set. I also was very cautious choosing the right models for both retrieval and generation. Having said that, even with local systems, we demonstrated our concept, we demonstrated that the RAG system helped to produce a higher quality than the baseline. Limitations, like I said, like lightweight models remain weaker than large cloud-hosted systems, of course. Retrieval misses still degrade generation quality. Future work, I'm hoping to improve a bit. Maybe if I can find uh, like if I can work on a better environment, I can maybe go for RAFT, the next step, or the graph rag is also very important to me. Again, for my new job at Uni4. Conclusion: we successfully implemented a lightweight enterprise-style RAG pipeline. BGE retrieval plus Tiny Llama generated improved grounded QA performance. Yes, the improvement was not large, but at least it proved the concept. Project demonstrates practical and reproducible local RAG workflow. Thank you very much. This was it. The video presentation is the one that I'm doing now. And final note from my side, I've been in this course for this degree and for like 1.5 years. And honestly, one of the most valuable courses I've taken was the LLM, specifically because of my new job at Uni4. So thank you very much and see you inshallah in next courses in the same degree. Thank you. Bye bye.